Welcome, my name is Iman Jasser, a master student at Ankara University, Iraq. This scientific paper deals with comparative analysis of face recognition based on multiple feature domains. Introduction. The face is a highly relatable biometric feature for authentication and identification purposes, as it enables the recognition of individuals in a realistic manner. Facial recognition involves the calculation of unique facial features, such as the size of the nose, breadth of the brow, and the area of the forehead. The human face recognition system is exposed to many attacks, the most important of which are physical adversarial examples and face morphing attacks. This is an example of face morphing attacks. Image B is a morphing image from subject A and C. Existing face recognition method. The face recognition system consists of the following steps. 1. Pre-processing uses technique like contrast, stretching, and picture normalization to enhancement the image. 2. Feature extraction is utilized to extract the key feature from a face image. 3. Classification. This is then carried out using classification methods. Identification. To find the image that most closely resembles the new image that was classified, as shown in the general structure of face recognition system. First, input image, pre-processing, feature extraction, classification, and the last step, identification. Existing face recognition based handcrafted features. The most famous type is local textual approaches, always perform hair robustness to light, noise, posture, fluctuation, etc. Methods for face recognition based handcrafted features are divided into two categories based on the domain of feature: special and transform domain methods. Special domain feature. Special domain is the technique that adds invisible watermark data into the pixel value of the host image. Special features refer to the characteristics and patterns that are present in the special arrangement of pixels within an image. There are several techniques available for extracting special features, such as scale invariant feature transform, local binary pattern, GLCM, and histogram of oriented gradient. These techniques are simpler, more efficient, and faster to implement. Transform domain feature. The transform domain converts and represents the original image in the frequency domain using a forward transform. Can be used to identify local geometric characteristics such as the corner of facial outlines and the lines that run along them. Transform domain technique such as discrete wavelet transform, discrete cosine transform, FWHT, half transform, and Fourier transform. Publicly databases. There are several image datasets set of face images, and they differ depending on factors including dataset volume, varying lighting, facial expression, and complexity. Table 3 gives detail of the various datasets based on image number, subject number, image format, image resolution. It was observed in the collocation of paper from 2018 to 2023 that most researchers focused on ORL and YLB due to the change in angle, lighting, and facial expression, which help in training the system well. Comparison of face recognition methods. The performance of the human face recognition system varies concerning feature extraction method, classifiers, feature selection, and evaluation matrix. These tables compare the results of different face recognition system algorithms for different extracted feature sets. Method for face recognition based handcrafted feature are divided into special domain and transform domain. In special domain, use Gabor filter as feature extraction with GWO as feature selection with KNN as classifier with YAL face dataset. The result is 97. Another example for special domain, GLCM as feature extraction without feature selection with CSVM and KNN is used as a classifier with their image. The accuracy is 79. In a transform domain, for example, used discrete wavelet transform and discrete cosine transform as feature extraction with DFA as feature selection with nearest neighbor is used classifier with ORL and DL used dataset. This is the result in ORL and YAL dataset. From our point of view, the special feature domain is the best as it requires less time and operation compared to the transform feature domain. It was noted that combining MR, ELBB, NI, and LBQ in the special feature domain predict distinct outcomes. In the transform feature domain, we found that the combination of FR discrete cosine transform and discrete wavelet transform yielded the best performance. Conclusion. One of the most commonly used biometric authentication systems is face recognition technology. This system uses multiple processes to calculate unique facial features, such as forehead size, brow breadth, and nose size. This paper discussed two categories of handcrafted feature extraction method, special feature and transform feature domain. In the feature, we plan to compare deep learning to handcrafted features and then compare their performance. Thank you for listening. Goodbye.